Dictionaries are a very interesting part of the Python programming construct. It's a particular data structure that stores data as key value pairs, and this combination of words, key value pairs, is actually very important. So the easiest way to think of it is thinking of you trying to fill out a form. Usually you have something like name, and then you're supposed to enter your name, and then phone number, you're supposed to enter your phone number, and then you'll be prompted for age, you put in your age, your height, and all of that. So that's an example of a key value pair. So for example, your name is the key, while the value is what you choose to put in there. Now, the key is usually immutable. In other words, it doesn't change, it's always fixed, while the value can vary, you can change it. So we can use one form to gather data from 1,000 different people. But guess what doesn't change? The prompts, right? The name, age, email, all of that. They are fixed, but what's variable is usually the value. So each key has its own value. So this says a dictionary is a Python data structure that stores data as key value pairs. Think of it like a real dictionary. If you go into a dictionary, usually you have a word and then the meaning, right? Now that word is considered the key, and the pair is the meaning of the word. So this kind of what it looks like, an example of a dictionary in Python. So you have the student, a dictionary called student. You can see the name, and we have the quotation marks over it because it's a string, right? And then equals to another, the name, the specific name in this particular case, which is Alice. It could be Peter, it could be Johnson, it could be anything, but name is going to be permanent, and then the age, and then the major computer science. So that's an example of of uh, of a dictionary. But pay attention to the punctuations, right? You can see it's usually the key and the value are usually separated by a colon, and then you have a comma at the end. That's the end of one key pair, key value pair. And then you go to a second key value pair, age, colon, 21, and then a comma, and then you go to a third. So you can actually have 100 different key value pairs, each key value pair separated by a comma, and then the key and the value themselves separated by colons, and they are usually all encapsulated inside coily braces. And that's exactly what a dictionary is. So the key idea of a dictionary is that a dictionary maps a unique key to a unique value. So it's unique keys mapped to unique values. So this is what the syntax, just like I had already alluded, looks like. You have your key 1, key 2, key 3, and you can go down to key 1000. For each key has a unique value, has a value. Each unique key has a value, and then down, down, down that way. So this is an example where, for example, I'm talking about a car. And if I want to model this car, right, I can gather all of the information I need from the car. I know the brand, I know the model, I know the year. Guess what else I could add there? I could add the color. I could add any number of things, right? That could be the features of a car here, and then capture the specific values there are for each of the keys. So the specific rules is that keys must be unique, and then keys are also immutable. In other words, they don't change. If you remember when we talked about tuples are immutable. Strings are not necessarily immutable, but they have to be immutable in this particular. In other words, once you put it in, it's locked in. And then the values can actually be any kind of data type. It could be a string, it could be a float, it could even be a boolean, right? Whatever it is, it can be any data type. So here I say the mutable actually means unchanging, unalterable, or incapable of being changed over time. It describes things that are fixed, permanent, and not susceptible to variation. Those are the specific rules, right, that guide dictionaries. Here again is an example of a dictionary, but in this particular case, I'm trying to access information from this dictionary. So if I look at a car, for example, following the syntax for a dictionary, we have your brand, and then we map it to a value that is called Tesla, and then I have a model, and I map it to model 3, and I have a year, which is my key number 3, and then I map it to 2021. What if I want to pull information about the brand of this car? All I need to do is come, write out print, open and close you know your parentheses, and then I put in the car, which is this, and then I use a square bracket to pull out the brand. So because I'm pulling this brand, once I put in this brand, what I'm actually doing is I'm calling for this value, which is why you have an output of Tesla once you do something like this. So if I'm looking to figure out what the model of this car is, I do the same thing. I come in here and I type in model, and then it would return model 3. If I'm looking for the year, I do the same thing, pull up year, put it in here, and then it will return 2024 for me. So notice something, like in the example that we just did, right? This is the way I pulled this up. But what tends to happen? What if um I'm calling for brand, but there is no key value pair that is brand? What happens is usually it will create an error, right? So which is why a safer way of writing the same thing that you just wrote here is to use something like car.get, and then you say brand. Let's say I didn't put brand and I put color here, right? It would return none instead of throwing up an error. So that's why it's a safer option to use than to use this in case, because there are certain times you've created a program and someone is trying to make a call to the key value pair, and all of a sudden it returns an error. So ideally it should return something like none or like it doesn't exist. And for you to create that kind of insurance, you use this versus using this. So dict square brackets key, right, would return error if the key is missing or it's not available. But dict dot get with a key in within the parentheses would usually return none. So the next thing is I can decide to add a new item, right? So I talked about color before. Color wasn't there, but now I can add a color. And how do I do it? Just on the line of code, I just include car, quote unquote, open and close brackets, and then I could put in whatever key I want there and map it to a particular color. Or if I want to update an existing item, we already had year to be 2024. I can just come in here, do car year is equals to 2025, and it will automatically change 2025. Now, if I add these two lines of code, right, to what I already had here or here, guess what? This is what is going to return, because now I will have the brand Tesla, model 3, year 2025, and then color, it will give me red. Color was not here initially, but just by adding this line of code, you automatically get color included in that dictionary. So what if I want to loop through, and we've done an example like this in a previous course. and I said in, for example, is a specific keyword in Python. And if you go use your for statement and introduce in, right, you're essentially saying for each key within this particular dictionary, print out the key, and it's just going to go run a loop and print out every key within that dictionary called car, right? To loop every one of them and print them out. So we can also loop through the various values. And this is what you have for the value in cars.values, right? You can do the same thing. Or if you want to loop through both of them, instead of just writing it individually, you can just come in here. Notice what's happening. First of all, you do your for key first, then comma, and then you bring in what you have here, value in cars.items. Notice what changes here, like all of the items within the dictionary. And then you say you now ask it to print the key and the value. And if you do that, it creates this particular output that you have here, which is your brand, your model, your year, your red, which is exactly what we have here. That's how you loop through a dictionary. So as in other data structures that we have dealt with in the past, a lot of data structures have methods, right, in them. And a method is a type of internal function that helps you do something to a data structure. So in this particular case, we're trying to do something to our dictionary, right? So if I just say something like dict, which is your symbol for dictionary dot keys, it will automatically return all the keys that you have. It doesn't return the values, it only returns all the keys. If you want to return the values, you say dict dot values, it returns all of the values. Dict dot items, it returns the key value pairs. So that item is representative of the key value pairs. And then you say something like dict.get keys, which is a safe lookup, right? Think of it like a table. If you want to go look it up, that's what you use. So remember, I used .get in place of, let me take you back here, in place of just calling this particular element within the dictionary directly. It returns none, and it's a safer way so that you don't it doesn't throw up the error message where it's saying that the key is missing. And then you have dict.pop, which is essentially if you want to remove a particular key, all you need to do is write dict.pop and then you include the particular key you want to remove. And these are really good and useful dictionary methods that you can incorporate when you write your code. So what if I want to represent a user profile, right? I'm trying to create a user profile for a program I'm writing, right? How do I want to do that? And this is an example of how you do that, right? So you say username, and then you create the space for the person to enter their name. And eventually we are going to go do figure out how to actually use a dictionary, create a dictionary, and then all of a sudden the user actually inputs the values, right? And that's in user inputs. Followers 1240, verified, true, and then my interest, AI, robots, and manufacturing. So this is a real world example of data modeling, right? Using dictionaries. The other thing is a dictionary can actually contain other dictionaries. So if you look at student, right? Student is a dictionary by itself. And how you know is you have your open braces, curly braces, and close curly braces, right? So that's one dictionary. But inside that dictionary, you have another dictionary that is called students, right? And colon. So this is how you know it's also a dictionary. It starts here, but inside it is you have this key value, key value, and then you have another dictionary here, key value, key value. You can actually do something like this. So to access, for example, student one, I type in something like this, student one, and then if I want to make sure I'm picking up only one of the keys, which is name, I write in name. But what's that name? What is it going to return? It's going to return Alice, because that's what the name for student one is. So, and that's why you get the output. So this is typically called where a dictionary resides within a dictionary, or multiple dictionaries reside within a particular dictionary. We actually refer to as nested dictionaries. So, another way to look at a dictionary is that it actually behaves like a lookup table or a hash map, right? So just like you have your Excel sheet, right? It's like a lookup table. You have this and then it's mapped to this value. This, again, I talked about this in terms of like your typical forms that you fill out. But the good thing about it is that when it comes to speed, for people that are really into computer science, right? Creates an average lookup time, which is the 0, 1, you know, and irrespective of how large this dictionary is, you can expect a certain level of consistency. It doesn't waste any amount of time. So even if I have 1,000 keys in a particular dictionary, let's say it takes me 0.001 seconds to pull up an item. Even if I change it from 1,000 keys to 1,000,000 keys, it will also take me about the same amount of time to pull up those keys. And that's why it talks about the 0, 1 average lookup time. And that's for accessing. And I think that's where I stop with this. I'm going to, look up for the next video where we go through a couple of examples, and we're actually going to go to a Jupyter lab to do a couple of examples and further review dictionaries.